Okay, hello, welcome to this Ask the Expert session on building intelligent apps with Azure App Service. I'm going to be sorry if someone could mute the mic there. I'm going to be your MC for this evening. I'm Stefan Chaka, one of the product managers here on Azure App Service, and I am joined by Gaurav Seth and Tulika Charari, who also work with me on Azure App Service. So first off, we're going to go through a couple of slides and sort of this miniature walk-in demo to sort of give you an idea of what intelligent apps can sort of mean to us as web developers on the platform. So first, just a couple of general architectural approaches that are out there. This slide and the URL up at top is showing you one of the samples that's out there that gives an example of integrating ChatGPT and LLM technology into a web app. This is actually a demo that's linked to from our documents for Azure OpenAI, and it's got a fair number of moving parts, but for us as web devs, it actually deploys the main website that you interact with, as well as sort of some of the code that calls into the back end, and it runs as just a plain old regular web app running on App Service. In a similar vein, there is a more complicated architecture that I'm showing here. Again, it's sort of the recurring theme, which is that you have a web app running sort of in the middle of it all. And I'm going to show you this working here in a second, but the main takeaway is the common theme is that you write web apps using common technologies, Node, Python, you name it. And then those apps need to interact with your AI technology, your models, your APIs. And typically, for example, in the case of ChatGPT, that's exposed to some kind of an API by way of Azure OpenAI. And in this example that I'm going to show you in a sec, they actually use the Azure Bot framework to act as a backend between the Python front-end app and myriad backends, including ChatGPT, Azure Cognitive Search, Bing Search, you name it. So let's take a quick look at this app running in action. I've got it up here. Like I said, it's the front end is a web app running on App Service. It's just a Python web app. And they put it together so that you could demo either doing searches or chat style functionality. And so I've already run both a sample search and sort of a sample chat query ahead of time, because again, this app does throttle underneath the hood. And on this page, again, it's a web app. You put in an ask. It will then run it against the backend models. And in this case, it will actually retrieve links and summaries to a pre-generated index, in this case of about 10,000 publications that were basically indexed by generating the vector embeddings off of Azure OpenAI and then storing those as an index, a vector index inside of Azure Cognitive Search. And then similarly, another aspect of this app is you can go out and interact with a variety of search backends, again, through this Python front-end app. And what's pretty cool is, again, the sample can actually connect to things like Bing Search, ChatGPT, plain old SQL, Cognitive Search, you name it. And again, earlier, just in the interest of time, I just said, hey, let's use the Chat GPT backend for this sample. And I just gave it, a random question. Hey, what is a Monte Carlo simulation? And again, here it's generating the response text off of OpenAI in conjunction with a lot of the information that was already trained into the model earlier. So again, main takeaway here isn't about how to go build or use an LLM. It's the concept that you can have your standard web front ends connected to an AI backend. And that's sort of how you can bring AI power and intelligence to your existing apps. So let's break it down a little bit, more simplistically. You have a web front end written in your favorite language. Probably for early days, you can go ahead and hook it up directly, for example, to Azure OpenAI, because if you've ever worked with OpenAI, it ultimately gives you a REST API endpoint. And so just like you'd have a web app talking to an API that you built or a third-party API, you can just have a backend to your website interacting directly with OpenAI, doing request responses. And then again, you can also integrate some optimizations, which probably many of you have heard about. Some kind of look-aside cache where you can cache the vector embeddings that you're not always going back to OpenAI. Now, having it said that, this is an intentionally simplistic approach, right? You can already see just from this discussion that you potentially either start cluttering up your web code or a backend that's running right beside your website that has to do a fair amount of heavy lifting just in terms of, hey, do I go call OpenAI? Do I do a look aside, look up, things like that? And so, unsurprisingly, the guidance is over time as you are starting to build out longer term plans and longer term integrations of AI intelligence into your apps, separate out those AI interactions into a separate backend infrastructure. And what I'm showing here is just one example. Okay, it does not require that you have to use these specific technologies. But as many of you have probably worked with before, a classic way of hiding a more complicated API backend infrastructure from your websites is putting it behind an API management front door using the Azure API Management Service. And then that way, underneath the hood, you can decide how you, for example, integrate some kind of index lookups to cut down on the number of calls that have to feed in to Azure OpenAI. Another aspect of this design shows putting API management itself as a gatekeeper in front of your Azure OpenAI endpoint. And I've got a link here in a bit to a tech community article that went into detail about setting it up. It's actually another great use case for using Azure API management, because one of the things APIM does really well is it gives you the ability to version the underlying implementation of an API backend over time without actually churning or impacting your upstream web app. And so again, if you've worked with things like Azure OpenAI, there's like different versions of ChatGPT that come online over time. You as developers may be building different fine-tuned models that you want to switch between. So moving that all behind an API and then itself putting the actual OpenAI implementations behind API management, it's a great way to give you that versioning flexibility. So I'll just close it out here, this quick intro here on this slide with the links. It's got references to all of the GitHub repos that have the various examples for interacting with OpenAI. And also it has links off to a number of different Learn docs that go into more details. And then also towards the bottom here to two great tech community articles, one going over that pattern of using API management with Azure OpenAI, and another one that points off at how you can use Azure Cache for Redis, specifically the enterprise version, to help implement a vector index vector database that is one of those techniques for cutting down on the number of OpenAI calls that you ultimately have to make. So that was the quick slides, just little lightweight demos that we wanted to go through. I think at this point, let's switch over and see what kind of questions we have coming up in the chat, and then all of us as experts can sort of weigh in and give our input and advice. Okay, well, I'll tell you what, since it looks like we have some things coming in, let's go ahead and, for the heck of it, start with, let's see, we got a question here. How easy is it to migrate on-prem .NET or Java applications, and then somehow bring AI capabilities into those applications after you've migrated them? So, that's actually, yeah, quite a bit of sort of two different concepts going on there. I'll tell you what, let's actually switch over to Gaurav. If you could weigh in just sort of, what's involved in those early days when you're first taking a look at an on-prem app, again, .NET or Java, and you want to migrate it up onto App Service.
Yeah, that's a great question. So again, as an app services engineering team, we have been continuously investing in building tools which are helping our customers quickly and seamlessly migrate their web applications to app services, web apps. So we have tools all the way if you're looking to migrate entire data center to if you're looking to migrate just a single web application. And the idea behind having multiple tools is behind the scene, the kind of configurational checks that we execute remain the same. But the big difference is the scopes for all the tools. So if you are looking to migrate multiple web servers at a time, if you're looking to do a bulk discovery, assessment, and eventually a bulk migration of your ASP.NET and Java Tomcat web apps, you should look at the integrated experience that we have built along with Azure Migrate. Now, if there are scenarios where you are looking to only migrate a specific web server, in this case, an IS web servers, you could also look at a PowerShell based experience. And if you're looking to migrate just a single ASP.NET web application from your on-prem server over to App Service, you could actually look at using the App Services migration assistant. So that's about different tools that we have already invested and made available for our customers to use when it comes to migration. Now, once you have migrated into App Service, that's where I should say the whole richness of the App Service platform comes to the fore. So things like regular maintenance to patching, I mean, that sort of things obviously we take care of. And as we've been seeing, eventually, if we talk about open API, open AI sort of capabilities, I mean, we are talking about a web app communicating securely and seamlessly over to an API endpoint, and that is where your web app could be the front end in a language of your choice. Probably if you're even using an on-prem web app being migrated, and then have it communicate over a secure channel to the API backend. And in addition to that, like as we've seen, that you could again have throttling in your backend, but you could again cache and have a more seamless experience for your customers on your front end. So that is where you can take advantage of things like auto scaling on your web app. So yeah, I mean, that's the way I would pretty much look at the end-to-end flow of migration to modernization of your web apps.
Yeah, cool, cool. Yeah, and also, I mean, to add to what Gaurav mentioned there, one of the things frequently to think about is, with the AI generation that's going on right now, this is a great example where apps that are sort of mission critical but still potentially remaining on premises, it becomes harder and harder to sort of be able to integrate those into the AI wave and the AI evolution if they are sort of left behind. And so that's something where being able to take those apps and again, be selective about it, but the ones that matter, the workloads, the customers that matter, and bring them up into the cloud, because now you're moving those apps a lot closer to all of the other assets that you ultimately are going to be building over time that are going to give you that ability to say, hey, can I take my data? Can I integrate it into various AI models? Can I present that in a way, a coherent way to my customers? And the reality is that innovation is almost exclusively going on up in the cloud versus on older data centers or running on prem. So yeah, great question. Definitely spans a lot of concepts, covers a lot of ground. Um, so looking at what we got coming in. So you had mentioned actually interesting, about auto scale. And so one question here is, actually, ironically, Gaurav was talking about it here not too long ago, a few months at Build, which is how is the automatic scaling feature that's out there in preview? How does that, differ from the auto scale feature that's been around for a very long time on App Service?
Yeah, another great question, I should say. So, again, the idea is that app services as a platform for us, auto scaling or scaling in general has been like one of the very important fundamental pillar of the service that we offer to our customers. So we always had the option of manual scaling where you could simply drag the slider and get extra instances or hardware to say so for your web app. Similarly, we also had the auto scale capability, which was more targeted towards what if you wanted a scheduled based scaling, something like on weekends and weekdays, I want a different scaling, or morning and evening, I want a different scaling. You could set up schedules. Or if you're looking at a metric based scaling, that based on CPU or a memory usage or a data in, data out kind of a parameter, I want to set up a scale, I want to scale out, I want to scale in. Perfectly fine, you could do all of that. But we also constantly heard the feedback from our customers that they were looking at more like an automatic, or what we simply call as a cruise control or a cruise mode kind of a scaling, where the idea is that, I mean, as customer, you tell us the maximum burst that you want your app service plan to scale, and then you tell us the max and the min boundaries for individual web applications within the app service plan. Now, having said that, you could actually have all the web apps scaling to same boundaries, or they could even have different maximums and minimums. And once you set those things in the UX or using a CLI experience, again, just using sliders, behind the scene, based on the incoming HTTP traffic, we do the rest. So again, rather than you trying to set up metrics and doing the heavy lifting, in this case, we take care of the entire, I should say, the intelligence built into the scaling model for us, based on which we would like scale you out and scale in the web app based on the incoming traffic. So yeah, that's for me is a very big
Fundamental
difference between.
between the two. Yeah. Yeah. I mean, look, another thing that, with what Gaurav's talking about that he touched on, and again, I'm thinking about it here specifically in the context of using the AI backends and open AI, is realistically these days on app service and our peer services, let's face it, for web developers, you can probably scale out your web tier way beyond the capacity of your back ends. And the reality is that's true even for just like plain old, pick your favorite database back end. And so I'm just thinking about it because, again, with something like Azure, with Azure Autoscale, as well as the automatic scaling feature, you're in the situation where you can end up burst scaling out your presentation tier way beyond the capacity of, for example, that back end OpenAI endpoint. And so, again, it's something for folks to think about because, sometimes, like if you think about traditional SQL technologies or NoSQL, right? I think people are pretty familiar. They know how to optimize it. And also, quite frankly, people know how to brute force it, right? Just like get me a bigger database, right? Or as they say in Star Trek, I need more power, Scotty. So, but with something like OpenAI, it's still there where you probably don't, want to be running insane amounts of traffic to your specific OpenAI endpoint. And so that's something to think about. Again, sort of reprising what I mentioned earlier. If you put something in between your presentation layer and your OpenAI endpoint, like API management, you can actually set throttling limits just to make sure that your web app doesn't accidentally overrun the back end. And then similarly, the feature Gaurav that he manages with automatic scaling, there are actually tuning settings you can put in there to tell us, yeah, go out and try to automatically scale that app out, but don't go beyond these limits. Right? Like, don't go beyond this number of instances because you as a customer could have already figured out, like, hey, wait a second, you can scale out, but not too far. So, yeah, definitely, it's an interesting area, and scaling definitely was. It's always going to be an exciting area of development for all of us.
Yeah, and just to
So,
add
okay,
on, there was there was an additional comment about the acceptable boundaries for scale. Again, I would say that, probably when you begin setting any boundaries for your web app scaling, I would advise to use probably a service like Azure Load Test, which where you can just throw a bunch of load at the web app to get like a baseline of what's the comfortable boundary in this case. And then again, based on different usage patterns and metrics that you get to see, you can keep tuning it. Again, remember, that's the goodness of app service as a platform, and everything is pretty dynamic, and you can come back and configure whenever you want. You really don't need a redeployment. So yeah, that's how I would look at it.
yeah, good, good. All right. So let's see. Again, looking at some other questions that have come in over time. Again, some of these can be pre-submitted. There's always my favorite, which is, how does Azure App Service make use of AI functionality today? Um, So look, there are actually a lot of areas where AI, not necessarily LLMs and Chat GPT, are getting used, but also areas where we do integrate with it. I was going to say, Tulika, do you want to talk a little bit about, like, what's been done in the diagnose and solve area in terms of actually bringing the LLM technology into the product?
Sure. So, one of the core features that we have for app services, and I think one of the most powerful features, is our ability to diagnose and solve. We do believe that you will have apps where you'll run into problems when you deploy it, or you just want to, monitor your apps, get more insights about from logs, from metrics. However, running things in the cloud is very complicated because you're not just talking about your web app, you're also talking about connection to several backends. And the ability to diagnose such problems is a hard problem. It's hard for us, and I'm sure it's hard for everybody out there. So, our first implementation of the AI was trying to make that experience simpler. What we've done is we have implemented a chat facility over there, as well as an LLM, which takes into account a lot of the learnings that we've had over the years, as we've determined what is the best kind of apps which can run on app services, and try to distill it out and give some kind of recommendation to you based on your app capabilities. So you can now go to the diagnose and solve, and you can take advantage of some of the facilities that we have already. And I think we are allowed to say that we are going to demo some of it
Yep.
at the Ignite
Yep.
session, which is coming,
Yeah.
where and it's going to be fun to show how you can take a bad app. Or, well, I think nobody writes a bad app by design. It's like we write apps, we make mistakes, but the diagnose and solve and the AI capability over there makes it easier for you to fix it.
Yeah, yeah, I love it. And actually, exactly to what Tulika said. Of course, shameless plug. Ignite is coming up here in a few weeks, and again, we expect there's going to be a lot of interesting things, both for app service and look. Let's face it, across the swath of Azure. In a few weeks' time. Specifically, here, the feature that Tulika is referring to. What's really great about it for us as web app developers is in the portal. If you look at that overview blade for a web app, it's right there. It's right up at the top in what we call the table of contents, diagnose and solve. It's one of those unsung heroes of app service. And when you click into it, it has myriad detectors. Again, it has the chat integrated support experience Tulika was referring to. And it is literally built on years and years of experience across the team on what goes wrong when folks run apps on us. And we're constantly updating and improving it. To give you a peek sort of behind the curtain, these days, some of those detectors are built in part using, probably unsurprisingly, things like Copilot, just to literally have, like, internally, we have a Copilot for detectors. And it's not that it's going to write these things, magically from scratch, but it helps like get you started much more quickly so that the folks who are the subject matter experts on the specific problem don't really have to spend a lot of time worrying about the initial setup and scaffolding. They can run the Copilot to get them all set up, and then they dive right into sort of KQL queries that they need to hone in on the problems. Another area beyond just sort of our ability to process telemetry and logs behind the scenes is in the area of scaling. Again, reprising that. If you happen to use our private cluster variation of App Service called App Service Environments, and specifically the newer V3 version, the way in which we scale customers in and out, and the way we sort of underneath the hood manage the allocation and deallocation of virtual machines itself makes use of ML models underneath the hood to try to train and learn and be able to maintain the right amount of buffers to sort of deliver VMs just in time when you need it. And another cool thing about it is we've been doing that now for probably, I don't know, a year plus on App Service Environment V3. And that's something where that's innovation that also will be brought over to the public multi-tenant version of App Service to also enhance and improve the way we, underneath the hood, handle that scaling experience for all of you running App Service plans on the platform. So it's an interesting take. Again, it's just something I know we talk a lot about, you and I building intelligent apps where you can build that AI functionality into your code, but also realize, probably unsurprisingly, underneath the hood, there's an immense amount of work to bring AI functionality, and not just LLMs, but just general machine learning capabilities into the platform. So yeah, good discussion. So, okay, looking down the list, there's of course then always the canonical question, which is, does Azure App Service have support for GPUs? That one I'll field directly because yeah, we get this pretty regularly. Look, in the near term, as in like let's say here in the next 3 to 6 months, we don't have GPUs today. Right. If you look in the portal, if you look in our docs, it's pretty clear. And certainly in the near term, it's not something that we're going to be bringing online yet. Uh, in large part because unsurprisingly, there's a finite amount of GPUs out there, and the way we sort of work, right, we're a general purpose web hosting platform. With that said, there is work going on behind the scenes to say, hey, what does it mean to bring AI workloads more directly onto the app service platform? And this is something where, I'll sort of give my 2 cents worth. And then this is more of an existential question for folks, for our customers, which is to tell us, like, if you see us at Ignite, come up to us and talk to us about it. Go ahead and provide feedback to us. But certainly what we see is obviously inferencing is an incredibly important part. And let's face it, after you're done doing all the hard work of training the models and fine tuning the models, probably the majority of the actual calls that are going on are to use the models, aka use inferencing. So that's something where to us that is a very interesting scenario. But underneath the hood, if you're running on, for example, the newer premium V3 SKUs, those run a mix of much more modern Intel and AMD hardware on Azure. It's not something we specifically provide any guarantees on what variant is running, but I mean typically they will run some variant of the myriad AVX instruction sets that are out there. Look, full disclosure, that's not going to somehow keep up with an NVIDIA chip or a GPU in terms of inferencing throughput, but it'll also be faster, right, than just using plain old instruction sets. And the thing that we are interested in the future is keeping a very close eye on, like, okay, can there be a rise in sort of what people choose to do in terms of inferencing right then and there inside of their app, or in terms of loading smaller models, sort of loading them right beside their web apps and making use of them. So I know it's a little bit of a roundabout answer. It's like I said, in the near term, we don't have GPUs yet, but it is definitely, it's a use case. It's a scenario we're very interested in. I think as time goes on, we'll get to a point where we're at least able to say, hey, for improved inferencing performance, that we'd start looking at offerings that fill that. And then taking a look at the real-time questions I see here, does the scaling give priority for VIP users, for mission-critical users? Well, look, realize on Azure App Service, ultimately, it's up to you in terms of sort of what you actually choose for the VM size and the power of the SKU that you associate with your web app. So it's something where we're not going to do anything auto magically or behind the scenes. It's like you intentionally tell us and you say, hey, App Service, I want to run on a really beefy machine and I want a bunch of them, and like we will give that to you. And similarly, you can say, hey, I'm not willing to pay that, or I don't need that. I can run on a much smaller set of machines and I'll go do that. And then to the earlier discussion about automatic scaling, we will metaphorically run you on like cruise control for an automobile, in the sense like you'll tell us, hey, this is the general size to use, but we'll take care of sort of automatically giving you more or scaling you in. So that's the thing for us, just specifically for app services, not really the concept of, like a priority user versus sort of a lower priority user. Think of it this way. All of our web apps are, from our point of view, high priority. You just tell us like what class of hardware you want, and then we'll just go out and literally run you on what you told us to run you on. Okay. So taking a quick time check here, it does look like we're getting pretty close to the end here of the stream. I just want to be mindful of that and our presenters. So what I will do here is actually wrap us up for this evening. Definitely want to thank Gaurav, Tulika, thank you very much for popping in here, fielding some of the questions, and just discussing about a lot of the different areas. And also for everyone who attended either live this evening, or again, if you're watching it after the fact, thanks for tuning in. Hopefully you've learned a couple of little nuggets here about how we run things underneath the hood in App Service. And definitely, if you're thinking about Ignite here in the coming weeks, love to see you here, whether you're physically coming or pop in for free. It's all online as well. So thank you again, folks.
Thank you everyone for joining. Thanks. Bye.